We are the team working on low latency live broadcast system sponsored by Intel. Have you ever met such a situation? The game live broadcast is about to start and you want to enjoy it together with your friend. But the reality is not as expected. The transmission is too long, so you have to wait and watching the buffer mark going round and round. Finally, you break down. Here is the latency we measured, which is more than 2 seconds. This is the result for live video cast under this situation. The latency is pretty obvious. The problem is that live video casting suffers high latency from transcoding and dispatching. Our project is going to deliver a robust FFM PEG-based low-latency broadcasting system. We tried our best to meet the requirements to reduce the latency to be less than 500 milliseconds with 720p video in LAN. Also, we ensure the stability of the video received. Here is the control flow for a complete video stream transmission, including the stage of encoding, transmitting and decoding. Let's come into details for each part. First, it's encoder and decoder. Multiple concepts are used together to reduce latency. We set buffer size to be 0 to make short segment duration. Shorter segments result in lower latency because a number of video segments are stored in buffer before starting playback, thanks to Intel architecture. We can take the advantage of hardware acceleration based on the integrated graphics card on Intel devices. At the same time, we set max B-frame to be 0 because B-frame can be decoded only after both previous and forward frames are received. A large number of B-frames means longer latency. Furthermore, encoding process starts after one complete GOP is ready. Therefore, the smaller the GOP size is, the sooner the encoding process can start, and thus the shorter the latency is. Chunk transfer segmented streaming is to make decoder and encoder work simultaneously. To decode a piece of video segment, we start decoding as soon as the first GOP is available instead of waiting for the complete video segment. Similarly, to transmit a piece of video segment, we can start sending data as soon as the first GOP is encoded. Meanwhile, constant bit rate is selected due to its fast speed. For transmission protocol, we use Transmission Control Protocol or User Datagram Protocol. They are fast, stable, and easy to implement. Now, please enjoy our demo. Currently, our average latency is about 45 milliseconds. First, we are sending a video recording of a stopwatch. The right screen is showing the video sent, while the left screen will show the video received. After the commands are typed, the system starts working. The latency can be calculated as the difference of the time on two screens. Now, the video is paused. We can see that it's 44.265 on the left and 44.308 on the right. The latency is 43 milliseconds. After several seconds, it's 53.768 on the left and 53.811 on the right. Now the latency is still 43 milliseconds. The system is pretty stable. Then, it's another demo. The right computer is running a game and sending the screen capturing to the left computer. The left screen is showing the live game. You can see that there is almost no delay. The player can even operate according to the right screen.